Hello and welcome back to the wide world of physics. It has been some time since I posted a video. It's been some time since we've had one of these discussions, but it's because we've moved to a different part of the country, and as you can see, the scenery behind me has changed and the table in front of me has changed, purely because it's a new location. Today we're going to reach into the proverbial toy box and talk about a gift that I have just received. It also appears I now have a new lab assistant. So today, like I said, we're reaching into the toy box and we're going to talk about these things. This is a gyroscope. I received this as a gift, and it's a very interesting, tiny little toy that has a lot of physics going on into it that is far more complicated than most people have ever made out. And they're actually quite old. The ancient Greeks came up with the word gyroscope. But the principle behind it talks about two different things, which we're going to discuss now. So the gyroscope is made up of two main parts, really. There's the spinning part in the middle, the bit that spins around, and there's this frame on the outside, which in this one is bright orange, which is great. So the point of them is that the gyroscope itself is the spinning bit, that angular momentum. There's a mass inside of it that is constantly spinning once I get it going. It will constantly spin, and the idea being, you get it to spin nice and quickly, it will stand up on a single point, which is what it's doing. Now, these are used a lot in different applications, especially since a spinning mass wants to, by Newton's laws, stay where it is. It's spinning around a central axis, which is this vertical bit in the middle, and it wants to stay spinning around that axis. It's only slowing down by the tiny bit of friction, top and bottom, from where the spinning bit meets the frame on the outside. Right, so let's look at the physics behind it now. So inside you have the spinning mass. As that mass spins, it generates something called momentum. Momentum is anything that has mass and is moving. It's mass times velocity is momentum. So something like an electron, tiny little thing, tiny little bit of mass, but massive speed. They move at 0.9 the speed of light, give or take. But they have tiny little bit of mass. Yes, electrons have mass. However, something like a planet, which is moving at 30,000 miles an hour, which is still fast, but not nearly as fast as an electron, but has a lot more mass. Momentum is the difficulty to stop something. So a planet is going to be very difficult to stop. An electron is very easy to stop. A container ship is very difficult to stop. So because it has a lot of momentum. It has velocity and it has a lot of mass. This is the same idea. It's just on a much smaller scale. As it spins, it generates momentum because it has mass and it is moving. In this case, because it's moving around, it generates something called angular momentum, which is considerably trickier than linear momentum. Angular momentum has it spinning around this central axis. As it spins, it wants to stay spinning along that axis. It wants to stay in this spot because of, generally, among other things, Newton's laws. Newton's first law says a body in motion will tend to stay in motion unless acted on by an outside force. This is spinning, but that law still applies. So as you can see, it's been provided with this very handy zip cord, which is toothed on one side, and there's a gear on the inside. And what happens is once I pull this, it's going to generate all of that angular momentum to spin that gyroscope around. And you can see it stays upright, even on a tiny little pedestal which it's sitting on, and it starts to spin, and it starts to counteract its own momentum, because momentum is a conserved property. We'll talk about that. And the idea is, as it moves, it's slowing down because of friction, and as it slows, it will go further and further around and spin faster and faster and faster as it goes until it falls over. So, as it spins, that angular momentum keeps moving it around. As it slows, the frame struggles to keep it upright, And in conclusion, it's all about momentum and maximizing that potential. Thank you very much for watching. Be sure to like and subscribe below, and make sure to check out all the other videos on this channel. Thank you very much.